We could have really put this in chapter 2. It would have fit really well in chapter 2 as well. I kept it with chapter 4 because it adds a nice little review of chapter 2 at the end as well. Now, some of the things to review chapter 2 that we did. In chapter 2, you did all sorts of reciprocal graphs where you had a polynomial on the top and a polynomial on the bottom. This reciprocal function is now saying we are going to learn how to graph if you put any function whatsoever on the bottom of a graph. If you know how to graph log, you can graph 1 over log. If you know how to graph a square root graph with a whole bunch of transformations, you now could do 1 over that. So any graph that you know how to graph, we're going to learn special rules for graphing 1 over that. Just in the same way, remember in chapter 2, we learned special rules to graph any square root of anything, where 0 and 1 stayed the same, between 0 and 1 was slightly above, and all of those ideas. So you could graph square root of any graph that you had before. This is very similar to that. We're going to learn special rules of what happens when you graph 1 over f of x. It is an area in mathematics where notation is a little bit weird because 1 over f of x is not the inverse function, which is like, you know how an exponent of -1 moves it to the bottom? But in functions, if you have a little -1, it's not an exponent, it's an inverse function. Question?
This isn't really related to the reciprocal ones, but you mentioned logs. On the exam, could we have like a composite function with logs?
Possible.
And we would just like follow it the same
You just
way.
have to figure it out and solve the same. I put a composite function of logs on your pretest of logs. I don't know if you remember when I said solve log 3 of log 4 of x equals 2 or something like that. That's one log function inside of another log function, but you didn't know about composition of functions at that time yet. Now, reciprocal functions, and I have this in your note, have a very, very simple rule. But unfortunately, the graphs are complicated that the simple rule doesn't necessarily help us completely. Here is the simple rule that you could get away with. If you know your original graph and you have a point on your original graph, all the reciprocal is doing is saying take your original graph and change the y values to 1 over y. And that's it. That is the only rule. But that only rules, sometimes it's a little complicated to see what happens as a result. I'm going to make up an example. You don't have to copy it down. I just want you to watch and see why the simple rule isn't quite enough for us to graph it completely. We are going to graph y equals 1 over x squared minus 1. So the graph on the bottom is x squared minus 1. That is a really easy graph to draw. It's a parabola shifted down 1 unit. We have no problem graphing y equals x squared minus 1. And our new idea, using the simple rule, says you just have to take a point and change the y value to 1 over y. That's the only rule, and then draw the graph. So we're going to see how, I'm going to take 5 points on here. I've got what? I've got negative 2, comma 3. I've got negative 1, comma 0. I've got 0, comma negative 1. I've got 1, comma 0. And I've got 2, comma 3. I got 5 points. I think if I do 5 points, I should have a good idea what the graph looks like. That seems like a nice naive thing to say. That should be more than enough. I usually only do 3 points. Okay, well, we'll see what happens. Now, what's going to happen to negative 2 comma 3? Well, the rule says that all you need to do is take the y value and change it to 1 over y. No problem. That's easy. I'll do it in green here. I've got negative 2 comma 1 over 3. Oh, I run into my first problem. This point is at negative 1, 0. So my rule says all I have to do is graph negative 1 comma 1 over 0. How do you graph 1 over 0? You don't. It could be a hole or an asymptote. Okay? In chapter 2, you'd have a hole if the non-permissible value cancels out, right?
Yeah.
And on this graph, the top is a 1. There's going to be no non-permissible values that cancel out. So we use a little bit of our previous knowledge and say, okay, I'm okay with this being an asymptote. Next point. I'm at 0, negative 1. If the rule says you take the y and do 1 over it, I'm going to get 1 over negative 1. Okay, that's not bad. That's going to be 0, negative 1 still, right? And another problematic point, but we already solved that. We're feeling pretty confident now. There's another asymptote. And then at 2 comma 3, we're going to have 2 comma 1 over 3. And we've done 5 points. Does the graph scream out to you what it's going to look like? No. So there are some other things that we're going to have to realize from this graph. We could use a little bit of cheating from chapter 2. Do you see the degree is bigger on the bottom? Degree bigger on the bottom means there would have been an asymptote at y equals 0. We can also cheat from chapter 2 and say, if you have a reciprocal graph, or if you have any kind of graph that's a fraction, any rational graph, and the top is 1, you're going to have no x-intercept ever, because you only have an x-intercept when the top is equal to 0. So with that, knowing there's no x-intercepts, I could say, well, it probably goes towards my asymptotes, and it does. But this reciprocal graph looks nothing like the graph that we started with. It's quite a bit different. So we're going to learn the strategies for doing reciprocal graphs. The main strategy is you just change y to 1 over y, but it looks like it's a little bit more involved because of asymptotes and stuff like that. So as far as steps go, we're going to draw the original graph on the bottom first. That's what I did here in blue. Draw the original graph, and then I'm going to actually get you to remember steps 2 and 3 together. Because step 2 deals with vertical asymptotes, and step 3 deals with horizontal asymptotes. So we'll just summarize step 2 and 3 as asymptotes. Okay? You are going to have vertical asymptotes. These never have holes. You are going to have vertical asymptotes at every x-intercept. Because it won't cancel out. It will be a non-permissible value. And so if your original graph has an x-intercept, that would cause you to have 1 over 0, not allowed, non-permissible value. Those become vertical asymptotes. You will have a horizontal asymptote if your original graph's y-coordinates go towards positive or negative infinity. So we need to have a description of this because sometimes they're not going to give you the equation. Or sometimes they're going to give you an equation that doesn't have a degree. Like what happens if I had sine x on the bottom, or log x. It doesn't have a degree, so I can't use my chapter 2 to say it has an asymptote at 0. But the reason we put an asymptote at 0 is if the degree is bigger on the bottom, what ends up happening is your graph will either go up forever or down forever. And if your graph is going up forever, its y values are getting bigger and bigger and bigger. And if the rule says you do 1 over y, If y is really, really big, like 1,000,000, 1 over 1,000,000 is really close to 0. So if your graph has arrowheads that go up forever or down forever, you will always have an asymptote at y equals 0. It's like saying the degree is bigger on the bottom. But it also happens with log graphs. It happens with the tan graph, but not with sine graph. So it's kind of a little bit weird. Actually, tan is its own messed up thing. We're going to leave that for Monday. It's too messed up to even worry about for the weekend. But we will deal with graphs that we haven't done yet. Like you haven't ever graphed cosecant, secant, or cotangent. And those sometimes show up on the exam. And they can be done using this special transformation. Yay! Don't look so excited. Okay, so that is step 2 and 3, dealing with your asymptotes. Then steps 4 and 5, you can rename them and put them together as nice points. Step 4 and 5 says any other points that are on your graph, just use the simple rule. Right here, I had -2, 3. The simple rule is just change y to 1 over 3. Here I had 0, -1. Change y to 1 over -1. In steps 4 and 5, I talk about like specific nice points. For example, does it make sense that if your y value is either 1 or -1, when you do 1 over that, it stays the same, which is called an invariant point, a point that doesn't change, okay? You don't always have to label invariant points. You can if you like. But anytime the y value is 1 or -1, it would stay the same. You can also notice that wherever you previously had a minimum, so you see how this vertex here is a minimum? When you do the reciprocal, that point now is called a local maximum. It's not the maximum of the graph, but if you ask all of its friends nearby, it's the biggest one. That's what a local maximum means. Just close by, it's the biggest one. So minimums become maximums, maximums become minimums when you do the reciprocal. And the last step is, once you've done a bunch of nice points and have your asymptotes, you just have to draw it towards the asymptotes. And you'll never have any x-intercepts because a 1 over graph can never equal 0. So on the second page of notes that I've given you, I've got examples. And I put way too much work on here. We'll make it even easier than this, but I wanted to show every single step separately, which is kind of nice to look through, but what we're going to do is we're going to take the original graph and right beside it. So first of all, I graphed the bottom, which is x squared minus 4, and that's given to us here. Then, steps 2 and 3, I said I put together, those are our asymptotes. Do we have any x-intercepts? Yes. We have an x-intercept at -2, so that's going to be a vertical asymptote. And we have an x-intercept at +2. Does your graph, original graph, go up forever or down forever? Yes. So we have an asymptote at 0. So step 1, draw your original graph. Step 2, do your asymptotes, which is actually step 2 and 3. Yes?
Can I just get a full explanation for y equals 0 asymptote?
Mm-hmm. So because our original graph is going up forever, its y values are getting bigger and bigger and bigger.
Yeah.
And the main rule says whatever you have as a y value, the reciprocal, it just changes it to 1 over that y value.
Yeah.
The bigger the y value, the closer 1 over that y value will be to 0.
Yeah.
If I put in a billion, 1 over a billion is not very big. Okay? Right? Like, I always think of it as like you're a very kind and giving person and it's your birthday and you made a cupcake but you want to share it with the whole world. So you take out a very sharp knife. How many people are in the world now? Couple million? Billion. I thought you said million. I was like, there's lots more than that. So you cut up your little cupcake into a couple billion pieces, stick them in envelopes, lick them all shut, and mail it to everybody. How much cupcake is everybody going to get? Next to nothing.
You're gonna cut that cupcake so small, we're gonna be cutting it to atoms.
I know, it's super small. So does that make sense?
Yes.
Why, if it goes up forever, we have that y equals 0. Now, nice points. I have 0, -4. That's going to give me 0, 1 over -4. And having that point in that section would be enough to draw that. I could take a point on my blue graph, say, if I plugged in 3, I would get 3, 5. Then I'll have the point 3, 1 over 5. And that's enough in this section to go towards the asymptote. Similarly, you're going to have -3, 1 over 5. And your graph is done. Did you do this in your grade 11? When I do this graph in grade 11, I give it a name. Makes me think of a sad face. People like the frown. So now that you see sad face, some of you are like, oh yeah, I remember doing it. You said, I remember being sad in math class. That may not be the connection.
I do remember the sad graph.
There's the sad graph. Okay, let's see the next one. See if you remember this one. So now I have x squared plus 1. Grade 11 was about doing reciprocals of parabolas. So again, right beside it, oops, that's not black. Right beside it, do we have any x-intercepts? No. No vertical asymptotes. Does it go up or down forever? Yes. So we do have a y equals 0 asymptote. Let's do some nice points. I've got 0, 1. That's going to be 0, 1 over 1, which is 0, 1. I would also have 1, 2. What's going to happen at that point? 1, 1 over 2. And this graph ends up looking like this. We had a name for this one.
That's not notes.
Yeah, it was called the speed bump. Boop. You're driving along with the car over graphs, like a little speed bump. So grade 11, this would have been now reviewed grade 11. The only thing new in grade 12 is you could have any graph on the bottom. So if you were asked to graph 1 over the square root of x plus 4. Well, first you could graph the square root of x plus 4 by taking the square root graph and moving it 4 to the left with transformations. Next, do we have any x-intercepts? Yes, we do. We have an x-intercept at -4, so we have a vertical asymptote at -4. Does the graph have an arrowhead that makes it go up forever? Yes. It's slow. Square root graphs go up forever slow, but they do go up forever, so we will have an asymptote at y equals 0. Next, look at some nice points. What's going to happen to negative 3, negative 1? Negative 3 comma 1? It's going to become negative 3, 1 over 1, which is negative 3 comma 1. What's going to happen to 0 comma 2? 0 comma 1 over 2. And we have enough points in this section to go towards the asymptotes. What about this section? There's no graph in the original one in that section, so there will be no graph on this one in this section either. And probably the most common type of question I see on the exam with reciprocal graphs, and you have one either in exam 1 or exam 2. They give you the graph. Here's the graph given to you, and you have to draw the reciprocal graph. And if you didn't know the rules, the final graph is really different than the original one. So first of all, do we have any x-intercepts? Yes. We have an x-intercept at -1. We have an x-intercept at 2. And 3, 4. We have an x-intercept at 5. Now there is an arrowhead here showing that the graph goes up forever. So we do have to add that asymptote. Now, if this was just a dot, if it just ended there, then we wouldn't draw that asymptote at y equals 0. But that arrowhead there says it goes up forever, so we have to also add the asymptote at y equals 0. Some nice points. -5, -1. Will still be -5, -1. -2, -1. Will still be -2, -1. That straight line will still be a straight line. In fact, straight horizontal lines everywhere will still be straight horizontal lines when you do the reciprocal. Because if you had a line at 3, now you'd have a straight line at 1/3. It might change, but it would still be a straight line. Now it's going to go towards this asymptote. Does it make sense that it has to go down? Because otherwise you would have an x-intercept, and 1 over graphs never have x-intercepts. Similarly, 0, 1, you're going to have 0, 1 over 1. And that's enough to graph this section. We have 4, -1. That's going to be 4, -1 still. And we had 6, 1, which stays 6, 1 as well. I was thinking, how hard would it have been if I would have started the lesson with, we're learning a new rule today. I'm not going to tell you what the rule is or how it's explained. I'm just going to say you need to take this graph and know what to do to draw this. And yeah, if you came up with the other classes were like, oh, maybe first you need to take a bunch of drugs, then spin around a bunch of times, take 2 different colors of pens and just have fun and see what you come up with. Because it looks nothing like what you started with, right? But there's a reason to it.
I mean, it almost looks like the only similarity is it almost looks like the reciprocal graph is avoiding the original graph.
It kind of is, right? Like when the original graph is going up, it says, I'm going to go down. If the original graph is here, it's going up, so it's like, I'm going down. Oh, you want to go down? I'm going to go up. Kind of avoids everything. And it doesn't like x-intercepts. So, okay. You have a worksheet there, and we're going to take the last 15 minutes to work on that and practice. And then it's going to be due on Wednesday. Optional, you can come pick up your take-home quiz already. If you don't want to do it this weekend, you can pick it up on Monday. There are 2 pre-quizzes online instead of 1 for this. So if you think you'll take it home and then feel guilty for not doing it, you could leave it here and get it on Monday. But if you, during the weekend, if you feel like, oh, I should have taken it, I should do it, well, you could do the pre-quiz. So, that's up to you.
Are the online ones long?
They're not super long, no.